Having the inertia values of the spin part correct, the last thing to do to have the complete inertia tensor is to set the right location for the center of mass. As the exercise text describes, the center of mass should be located 6 millimeters below the center of the BS. As you still remember, the BS center is at 22 millimeters, so we can now go at the center of mass and change that value to 22 minus 6 being 16 millimeters. We could also parameterize this value actually to the markers in the center, but that's for later. But this gives you an idea of the method you can apply, just typing the value of the center of mass and then moving it over to its desired position. Remember, this can only be done because we are now in user input mode for the inertia of the spin part. If we would do that from the other settings, atoms would automatically switch over to the user input method. Okay, now the inertia should be correct. We'll check it later in our simulations. The next thing we can do now is set the proper initial velocities. Velocity initial conditions. What we want to have is we want to have a spin of 80 rotations per second about the vertical axis, so about the global y-axis. We could select a marker on the global frame, but it might be more convenient to use this reference marker or use center of mass marker. We will use center of mass marker because that's typically where the solver will work about, and it's just a convenient choice. Center of mass marker being aligned in that direction, as we already know. So what we have to do is we have to define a value for the initial velocity, the initial angular velocity about the z-axis of the center of mass marker, and we're going to make it equal to 80 rotations per second, which can be done like this, degrees per second. This is just one way of typing it out in a convenient way so we can easily see what's going on and change it later on. Call this something like a parameterization string, but it's just more readable than just typing a value. Okay, that's it. Next thing to do is initial velocity. We need a disturbance. If we wouldn't actually put a lateral velocity in, the spin could continue for hours until it falls over. So what we also will do is we will define an initial velocity in x direction. Let's do this about the ground frame, and this velocity should be 10 millimeters per second. Okay, so now if we would run, we would see the part spin and move over, and let's check what's going on there.